In one of my previous videos, I was finding a power transformer for the tube preamplifier. I thought I'd show the completed project. So this is my tube preamplifier. Just power it on. There's some neopixels. The color changes during the startup phase, and when everything is warm, gets to red and then switches to a nice yellow. And I can turn it off if I want to. The tubes, EZ80 is the rectifier tubes for the power supply, 2 times ECC83 for the preamplifier stage. ECC81 is the final driver, set as a cathode follower. Display 3.5-inch touchscreen. This is a digital attenuator, so I can change all that. 256 steps, so an 8-bit attenuator, fully digital. It is logarithmic, so all the action happens in the end. If I would redesign it, I would reconsider that. I can select one of the inputs. So why a preamplifier? Well, I have built a couple of tube amplifiers. They need about 1 or 2 volts maximum on the input. And I'm usually using a network player, which is more than capable of driving that. But if I want to hook up my CD player or anything, then I need a bit more power. So this one has 4 inputs and 4 outputs, also a monitor output and a bypass setting as well. So I can select the input. I can set the names for the inputs in the settings. I can select one of the outputs. At the moment nothing is connected except my test source just for demonstration purposes. Otherwise I get copyright issues slapped on me for the music. So I can toggle the menus through here as well. I can select the bypass. I have the view meter going. A little oscilloscope. Spectrum analyzer. The line spectrum analyzer as well. Any other settings I can turn off. The backlight. Oh, I really like that. The settings, I can set the names of the inputs and outputs. So now it's fully open. So very simple. The design, let me get my draft schematic here. The design is based on a classic design. Let me just get it here. Well, so we have the ECC83 up here. There's a feedback loop with a trimmer I can adjust. So there's some trimmers, 1 for the hum and 2. These adjust the gain, so I don't need much gain. At the moment it's set to 5 times gain, and you should set it to the worst source that you have in your chain. So first amplifier, and then the driver stage, cathode driver, coupling cap, and then the output. So it is used in many preamplifiers, and there's a reason for that. It's a good circuit, so why not reuse it? Power supply is heavily filtered, rectified to EZ80. So I first designed it, or I emulated it in LT Spice to see if it really would work and what the parameters are. That worked really well. I had some doubt about some components, so I made a quick setup on my breadboard just to test the parameters, and everything turned out fine. So pretty happy with that. Let's have a look at the inside next. A look under the hood before I close it up. So we have the power transformer made with some AMCC 160 cores. Nobody does it, but I have the cores, so I use them. A little bit more hum, because there are lots more laminations. The former press bound 2mm cut on my CNC with a laser module, and then wound on my coil winder. I made a few taps for 235 and 240, 245 in case I make a mistake, but voltages are almost spot on, so that's fine. High voltage, heater voltage separate for the rectifier as well, and voltage for the other electronics, so the ESP and stuff like that. And this is the filter bank. So after the rectifier, it goes into this capacitor block, and then filters. Then we have in the end two separate ones for the last stage. So there's a little bit of decoupling between the channels, so they have each their own voltage. The capacitors are special caps or DC link caps. So they have a lifespan of 100,000 hours. So you cannot beat that with electrolytics. So they don't dry out. Everything is well over-dimensioned. Also the power drop resistors are over-dimensioned. Nothing gets even hot. It's all room temperature. Even the transformer of the several hours is still at room temperature. And of course the NeoPixel LEDs for the logo. Just on a prototype board, not worth to make a PCB for a few LEDs. They're spaced according to the letters, so they match them up. And yeah, that's about it. So the material is 1.5mm aluminum, and the frames, the rails are from Gitek in Germany. Very good quality rails. So very easy to make custom housing with that. So that's it. A look at the inside. Here we have the amplifier part. It's based on a classic design used in many preamplifiers. EZ80 as the voltage rectifier for the power supply. Two ECC83s, the input circuit. ECC81 as output buffer. Pot meter, some pot meters to adjust the gain of the circuit. So they're in the feedback loop from the amplifier, which improves stability and also adjusts the gain. So right now it's adjusted to 5 times gain. Capacitors are all Philips mustard caps, new old stock. Local guy had some at a decent price. Over the years I bought most of what he had from values that I expected to use. They're really good, but at the time it was just a standard capacitor, so nothing special. For the output I needed 1 microfarad, which I didn't have. I did have 330 nanofarads, a bunch of them, and I measured them all, and I asked AI to give me a good match. So I have 2 identical ones. And well, surprisingly he came up with some strange combinations, but eventually they're both exactly stacking up to 1 microfarad, so happy with that. As volume on the input I have this. This is the relay attenuator. Input and output relays. So I have 4 inputs for output, monitoring output as well, and a bypass. So that's why we have the relays up here. Relay drivers, input output expander. So the input is I2C, and that controls all the relays from the ESP32. Power supply, a bit over dimensioned, so nothing gets really hot. 2 times 5 volt and 3 volt relay, 1 5 volt for the ESP, 1 5 volt for all the relays and relay drivers, and the 3 volt 3 is for the input output expander. That's its own supply. ESP32 part with some analog input circuit for the digitalization of the sound. It does add a little bit of noise, so something you need to reconsider. And of course ESP32, rotary encoders, display 3.5 inch with touch. So that's about it. Input switch or voltage switch is upside down, as you can see. And I made a little contraption here, 2 of these, made from a cabinet that I recycled, cut up, and then made this very solid, some foam on top, so I can place an amplifier upside down. I can just shift them to adjust the width. So they're 2 separate pieces. Very solid, very stable. Doesn't fall over even with high weight on it. Very useful. So that's the inside of the preamplifier.